Hello dear students of class 10, how are you? I hope your preparations for the coming board examination is on hi-fi. Recently you had periodic test 2. I had gone through the answer scripts of many students. Some of them have done really well and still some of them are struggling with the basics of the electricity chapter. So in this video I have come up with the solution of the questions that were asked in the periodic test 2. The students, those who are watching this video from the other schools, you can take a screenshot of this question and try these questions on your own, and once you are done with this writing answers, you can verify the solutions from the video. So let us get into the solution of these questions. So the question number 1 was to find the least count of the ammeter as shown in the figure. So here you can see an ammeter over here whose range is 0 to 50 ampere. So let us see the range of the ammeter is 0 to 50 ampere. And what is the total number of divisions from 0 to 50? So if I start counting this, it will be like 5, 10, 15, 20 and 25. So there are number of divisions that is equals to 25. So if you want to find the least count will be like the maximum range divided by the number of divisions. Okay, you can remember this formula, number of divisions. So here the maximum value is 50 ampere and the number of division is 25, which means that 25 ampere is divided into 50 ampere is divided into 25 equal parts, and that is why each division measures 2 ampere. You can do this particular question in a different way. If you don't want to take the entire range and you want to solve only for 0 to 10, you can see there in 0 to 10 amperes there are 1, 2, 3, 4, 5 divisions, which means that 10 ampere is divided in 5 equal parts or 5 divisions. So each division measures 2 ampere, and this is the least count of the ammeter here in the question. I hope it is clear. Now let's move to the next question. The question number 2 is to draw a labeled circuit diagram. Most of the students forget the labeling actually. So the question says draw a labeled circuit diagram to verify Ohm's law. So if you remember during the practical, you have got a fixed resistor whose value you try to find. Let me call this R. You're trying to find the value of this resistor in the experiment, and to measure this resistance you need to put a voltmeter across it that will measure the voltage across this resistor, and we put one ammeter in series. So this is an ammeter and this is a voltmeter, and we need to supply a power source. So you can take a battery eliminator or any other power source, and the positive of this will be here because I have taken the positive of ammeter and voltmeter on the left. So we have to take care of the polarity. In order to control the circuit, we also need a plug key or a switch, and the most important thing in this circuit is the rheostat or the variable resistor. Since we have to take more than one reading, we need to vary the current in the circuit by using the variable resistor or rheostat. So this is a simple circuit that can be thought of to verify Ohm's law. Okay, so let me start labeling this. So as you can see, this is a voltmeter. Let me mention this is a voltmeter. This is an ammeter, this is a battery, this is a plug key, and this is a rheostat. Now, how does this rheostat look like this? If you remember, rheostat is a 3-terminal device. This is terminal 1, terminal 2, and terminal 3. So we use two ends of the rheostat or the variable resistor to make the connection. Variable resistance. I hope this circuit is clear to you, and if you are drawing this circuit, this will be minus over here. You get 1 marks for drawing. The circuit is also shown over here in the schematic diagram. Okay. Now let's move to the question number 3. The question number 3 is quite interesting. The question says, how would you connect 4 resistors of 10 ohm, 20 ohm, 30 ohm and 12 ohm to get an equivalent of 16 ohm? So how can you get 16 ohm? So if you see here, the value 16 ohm is greater than, I'll erase this, 16 ohm is greater than 10 ohm. So what we can start doing is, we can keep 10 ohm outside this parallel circuit, and we will try putting rest all 3 resistors in the parallel, and we'll do the calculation for the equivalent resistance. We're just giving a hit and trial. Well, there are a lot of methods to calculate, and by practice you can get there. So let this be 20 ohm, excuse me for that. So this is 20 ohm, this is 30 ohm, and this is 12 ohm. If I find the equivalent of 20 and 30, so if I find the equivalent of 20 and 30, so this will be 20 ohm multiplied by 30 ohm, 20 plus 30 ohm, 20 ohm plus 30 ohm. So if you have got 2 resistors in parallel, I am finding the equivalent of these two first. Okay, so if I find the equivalent of these two, the formula is 20 into 30 by 20 plus 30. So from here you can get the answer will be like 600 ohm divided by 50 ohm, and from here you get the equivalent as 12, and the equivalent of this 12 ohm and this 12, if the two resistors are equal in parallel, you know the resistance gets halved. So this is 12 ohm by 2. Same method you can calculate, and that will give you 6 ohm. You can try the calculation like this: 12 into 12 divided by 12 plus 12. That will come as 6. In case you don't get any of these formulas, you can also try 1 by Rp is equals to 1 by 20 plus 1 by 30 plus 1 by 12. You'll get to the same answer. Rp will come as 6 ohm. Okay. So this is the basic formula, and if you have learned these formulas, you can even apply these. Okay. So the equivalent of the 3 parallel resistors are coming as 6 ohm, and this 6 ohm and 10 ohm, so the R equivalent will be 10 ohm plus 6 ohm, and that is going to give you 16 ohm. So this is the required solution for question number 3. You can present your answers properly. Okay. Now coming to question number 4. The question number 4 is, in the given circuit, determine the reading of the third ammeter. So what's the third ammeter over here? This one, basically I'm calling it as third. So you have to find the value of this ammeter and the value of R2. This value also we need to find. So how to do this question? Those who are seeing this question for the first time, again I would say this is a very interesting question. So pause the video, take a screenshot and try finding the solution of this question. I hope you have tried now. So let this be the method 1. I'll give 2 methods to solve this question. This is 1. In the first method, what we can do is, Since we know that since R1 and R2 are in parallel, since R1 and R2 are in parallel, which means that the current will be divided. This 5 ampere that is coming here from the source, it is going to get divided here. So some of the current is flowing over here, and that is 3 ampere, and some of the current will be flowing over here. So if I call this as I1, and if I call this as I2, and if I call this as total current I, so from here we know I will be equals to I1 plus I2. And from here we can find the value of I2, which is not known to us. So this will be, let me change the color and get into black color. So this is 5 ampere is equals to I1 value is 3 ampere and I2 is not known to us. So let this be I2. And from here you can get I2 as 5 ampere minus 3 ampere, and that is equal to 2 ampere. So you got the value of current here. Now we need to find the value of R2. Now from the very concept of parallel circuit, we know since we are supplying 60 volt, this 60 volt actually gets across or is supplied to R2 and R1 also. The 60 volt is supplied to R2 and the same 60 volt is supplied to R1 also. So from here we can find the value of R2. For this particular resistor R2, you can see the value of V is known, the value of current is known. All we have to do is use simple Ohm's law to find the value of R2. So what we can say, R2 is equals to voltage supplied by current passing through it. So voltage supplied 60 volt and current passing through it is 2 ohm. So from here we can get the answer as 30 ohm. So there are two small questions, and if you are solving these two, you get 1 marks for this and 1 marks for this particular question. So now let us see a different method to solve this particular question. Those who are good with finding equivalent resistance, they can even use this concept. So there are two resistors R1 and R2. So if you are finding the equivalent of these two resistors, so let that be called as RP. Okay, this is the equivalent of R1 and R2, and you know the RP, I is equals to V by RP, that is total current that is flowing is equals to the voltage supplied by equivalent resistance. So from here we can say RP will be equals to V by I. Okay, we can, this is the formula you know, when we have got more than one resistors, the total current can be calculated like this. You can call IT I total. Okay, I total is voltage supplied by the equivalent resistance. So in this case the RP value we can calculate. So we can say RP is equals to voltage supplied is 60 volt. So we can write here 60 volt and total current flowing is 5 ampere. So we can use 5 ampere here, and that is going to be 60 by 5 is 12. So the RP is coming as 12 ohm. So what does this mean basically? The equivalent of R1 and R2 is 12 ohm. Since R1 and R2 are in parallel, since R1 and R2 are in parallel, we can use the formula 1 by RP is equals to 1 by R1 plus 1 by R2. We can put the value of RP that we have got, that is 1 by 12 is equals to 1 by 20. R1 is 20 over here and R2 is what we need to find. So if you put the values and do the linear equation, 1 by 12 minus 1 by 20, that is 1 by R2. And from here I hope you all can find the solution. LCM is 60. This is 5 minus 3, that is equals to 1 by R2. And from here this is 2 by 60, that is 1 by 30. I just skipped one step. I hope you can find it on your own, and R2 will be equals to 30 ohm. So you got the value of R2, and the R2 is how much? 30 ohm. Now the same concept we can apply over here. Since R1 and R2 are in parallel, it means that they get the same voltage, that is 60 volt, that is supplied here. Okay, so the 60 volt is supplied. Now again for the same resistor, you can see the value of resistance is known, voltage is known, you have to find current. So you can find I is equals to V by R. So V supplied is 60 volt and resistance is 30 ohm, that will be 30 ohm, and you get the current as 2 ampere. So you can find either current first or you can find resistance. Both methods you can use. In the first method we calculated current I2 and then we calculated the resistance. In the second method we are calculating resistance and then we are calculating the current. So you can use any of the methods in the exam to find the answer. This is the solution of question number 4. I hope you have understood. If not, then put your comment in the comment section. Now coming to the last question, a very easy question, a theoretical one. The question says write 2 points of difference between series circuit and parallel circuit. Well, there are many points of difference between series circuit and parallel circuit, but we'll choose 2 criteria of difference. Let us choose the criteria for difference as current. Okay, so we'll differentiate series circuit and parallel circuit on the basis of the current that is flowing in the circuit. So you know in series circuit that the resistors are connected end to end like this, which means that there is only single path for the current to flow. So if 2 ampere is flowing here, the same current has to flow through here and the same current has to flow through here. There is no other path. So it means that the current that is flowing in the circuit, it is equal in all other resistors. So we say current is same. Current is same in all resistors. In all resistors. Now let us take an example of parallel circuit. So in case of parallel circuit, let's say this is your resistor 1, and again we have further division here. So let's say in this particular diagram, let's say we have got 2 ampere current coming over here, the same 2 ampere current comes up to here, and now there are 2 paths, one goes up and other goes down. So depending on the value of resistance, the current gets divided. So let's say the current that is passing over here is 0.5 and the rest of the current goes over here. So in parallel circuits, you'll find that the current gets divided. The current gets divided. So we can write here, in case of parallel circuit, current gets divided. So you can write here total current is equals to I1 plus I2. If there are more branching, then you can write I3 also dot dot dot. Okay, this is the difference between series and parallel circuit on the basis of the current. Now on the basis of voltage or potential difference, let me draw one simple series circuit here. Okay, this is resistor 1 and resistor 2. Let's say I am supplying here 10 volt. I am supplying here 10 volt. Then what happens is, depending on the value of the 2 resistors, okay, the voltage that each resistor will be getting, it may be different. This may be getting, let's say this is getting 4 volt and this resistor is getting 6 volt. So what we see, what we are supplying is 10 volt, but the resistors are not getting 10. So they are actually, the voltage gets divided among the resistors. So if I call this as V1 and V2, so you can say the voltage supplied is equals to V1 plus V2, or you can say voltage gets divided in case of series circuit. So voltage gets divided and the division is proportional. So we can say voltage gets divided proportionally. Okay, now coming to a parallel circuit. So you know, in case of a parallel circuit, no matter what voltage you supply, the same voltage actually gets supplied to all the resistors in the circuit. So if I am supplying here 10 volt, so all the resistors in the circuit here will be getting 10 volt, 10 volt and 10 volt. So what does this mean? Voltage remains same. So in short we can write voltage remains same. Voltage remains same for a parallel circuit. So you can see a similarity actually. So in case of a series circuit, current remains same, and in case of a parallel circuit, voltage remains same. And in case for a voltage gets divided in case of a series circuit, and current gets divided in case of a parallel circuit. So these are the two major differences between series circuit and parallel circuit. And one thing to note, see children, if you know that there are more than one differences that you know, and the question is of two marks, which means that you are supposed to write the best 2 points. So in that case you should always choose the best points, not the common points of difference. You should write the best points in the beginning. So that's all. These are the solutions of 5 questions. I hope you have learned and you have cleared your doubts. And all the very best for the next exam. Till then, keep studying and all the very best. We'll see you in the next video.